So, welcome to lecture number 15. So, this is the second lecture we will have on varying thermoplastic composite manufacturing process. As we said early itself, thermoplastic composite has several challenges, and now there is a pressing and pushing need. So, people have started working on novel processes and also trying to tweak those processes which was very well established in thermo sets to get into thermoplastic here. And the automobile industry and aerospace industry, they have been working for a long time in metal forming. So, for them these processes tweaking became slightly easy. So, automobile and the aerospace are the two big industries which are driving through thermoplastic composites fabrication. So, in this lecture we will see three processes. One is compression molding process, the other one is autoclave for thermoplastic composites, and the last one is going to be injection molding process. In each of these topics we will try to see raw materials, toolings, process setup and advantage and disadvantages. Compression molding process. Compression molding process, it is very similar to that of the compression molding what we saw in thermoset. So, the compression molding process of GMT, glass matte thermoplastic, is a process which is moving forward, and there are a lot of parts which are getting made through this process. In compression molding process, it is very similar to that of your SMC. SMC what we saw in thermo set processes, with the only difference during the type of raw material which is used here. Here it is thermoplastic and there it was thermoset. So, GMT process is nowadays used for making very high volume parts, and volume parts as well as varying size variation and shape variation. So, this is the only process which is widely used for various thermoplastic structural applications. The process is 2 or 3 times faster than that of your SMC process what we studied earlier. So, what are all the raw materials which are used? So, the raw materials which are used for thermoplastic is a GMT, is a glass matte thermoplastic. The glass matte thermoplastic is predominantly made of PP, polypropylene resin, and continuous but randomly oriented glass fiber. So, here what people do is people try to melt impregnated GMT is the most common metal form which is used, or people also used the powder impregnated or discontinuous fiber reinforced GMT as a raw material. See, what people try to do is nowadays they try to take a PP or they try to take any thermoplastic resin, and then they try to add reinforcement. And today people have started working on natural fibers also, apart from glass fiber, carbon, Kevlar, whatever it is, or a combination. So, what people do is they try to mix, maybe through mix, and then they try to pultrude or extrude this and get an output. And then what they do is they try to slice it and make it into pellets, and these pellets are used for making these composites. So, this is one way, one processing route of making it. The other way of towards melt impregnation on GMT is already done, and then we try to take it, or in powder they try to mix it and then they try to get it. There can also be a sheet form of impregnation which is done with PP. So, people try to take, or what people try to do is they try to take a PP sheet and then they try to take a glass fiber, then keep a PP, they try to consolidate, get the requirement whatever it is, and then they make a sheet out of it, a composite sheet. the raw material is then pre-cut, pre-weighed, and then try to make a composite, and it is this one is called as a blank. So GMT is nothing but glass matte thermoplastic, is used for making compression molding. In compression molding process, we try to get the required output. So what is the tooling? Tooling, naturally you need to have a die. So in compression molding of GMT is similar to that of SMC, which we studied earlier. So you should have a mold which can be heated. So here this heating is uniform heating such that you get a proper consolidation. So the mold can be heavy duty, it can be used for making multiple parts, varying size. So heavy duty guidance systems are designed for not to open and close, to open and close and get the final part done very fast. So here we also have an ejecting system to remove the component from the die. So what are the processing steps? The first step is that the compression molding thermoplastic is a flow forming process in which the heat is applied to the composite sheet and it is squeezed between the molds. Then it is maintained for 30 to 60 seconds. Then afterwards the mold, it is maintained heat for 30 to 60 seconds. So then what they do is the mold is rapidly closed under very high pressure, right. After this very high pressure, then what we do is the part gets properly consolidated and then we try to get the required output. So first, the compression molding of the thermoplastic composite is a flow forming process, correct, because the material has to melt and flow, and it is done by heating the composite sheet, and then we try to squeeze it, and then when we try to squeeze it, what we do is we keep it in a cavity so that it gets the shape. The mold time is 30 seconds to 60 seconds. A robo is used to place the preheated blank in a mold. The mold is rapidly closed under pressure to form the GMT and held close unit the part for solidification. The blank design is critical so that you get a good part consolidation. A well designed blank pattern is necessary for producing a good quality output with uniform glass distribution with optimum properties. So this is what it is. So what we do is, this is what is called as the charge. So this charge is nothing but the thermoplastic and the reinforcement. This is placed, and then what we do is, this is what we say, you make a blank or whatever it is. So this is done, and then this is kept inside a die. So in this die you try to maintain a temperature, and then here is the pressure what we apply, and then you try to have with a constant time. During that time the consolidation happens, and here naturally what we do is we try to take excess charge, so that what happens, this charge flows through this small dent which is called as a gutter. So this charge flows to the gutter. Once the gutter is filled, it tries to put a restriction, and then restriction of the further flow. This helps in consolidation of the shape of the charge to the die. So this is what happens in this process. This is compression molding of GMT. So why do we provide heat? The heat is used for proper consolidation only. So initially we try to heat before we apply pressure. In compression molding, the heat is supplied to the raw material before placing it in the mold, so that it tries to take into a semi-viscous state, not completely viscoelastic, but at least to a softened state. The PP is based GMT, we try to take it to 200 to 230 degrees Celsius, and then it is kept inside the mold. So then inside the mold, the water is cooled and the temperature is kept around about 30 to 60 degrees Celsius. So the pressure flow of the blank is applied by moving the part up or down to get the required one. The speeds with which it is operated is 80 millimeters per second, and this is much faster to that of your SMC. This is the most fastest technique in producing the thermoplastic composites parts for requirements. The productivity is very high. capital intensive. The volume fraction cannot go more than 20 to 30%. This is the very important thing. These are some of the parts which are made out of GMT. So, here we can see that bumper beams are made, dashboards are made today. In automobile they are made out of compression molding GMT, and they are also getting reinforced. Please do not think it is not reinforced, it is reinforced. So, you can also see the painted knee bolster with molded in texture can provide a class A interior surface and heavy truck dashboards. So, these dashboards are used today in the trucks, and then whatever is the flash which comes out, that gets trimmed, and those materials are recycled. Since it is thermoplastic, it can be reused. So, these are some of the commercial applications today, and it looks like as though these things are made out of just thermoplast, but people have started making use of reinforcement in it, and they have made the chairs much lighter than whatever is the ordinary plastic chairs are. Of course, it is expensive. Now, the technology is getting refined. The helmets are made out of this technique. Okay. The other applications, like people have started making blocks which are blocks which are used in machine tools. They have done with this, and these are some of the covers which are used for storing some defense applications, wherein which it can also try to maintain very high compressive load. So, the next process of discussion is going to be autoclave, used for thermoplastic. The basics of autoclave last time itself we discussed, it is the same, but here there is a small modification. The thermoset is replaced to thermoplast. The rest all autoclave is the same. So, we will just quickly browse through it. So, is very similar to that of thermoset composite. The thermoplastic prepeg is laid on a tool. The desired sequence you try to maintain, and then and spot welded to ensure that the stacks whatever are there, they do not move. There they will never move in thermoset, but here in thermoplast, since it is viscoelastic, you have to apply pressure. There is a possibility that the interplies can move. So, that has to be avoided. So, then we use a vacuum bag is placed in an autoclave, and the process, following the process cycle, the part is removed from the tool, and then you get whatever it is. This process has a very similar cycle of that of pressure and heat which is getting applied. The only difference between these two processes is the magnitude and the timing. So, the raw materials can be prepegs are available, wherein which you have carbon with the PEEK, and you can also have carbon with PPS. People are using it for aerospace application. This is finding lot of usage. So, you can also have nylon as for glass and Kevlar. Tooling, it is made out of stainless steel, aluminum, composite, wood, anything. You can have, it is an open mold process, because the other side, the second half, wherein which you are left free open, that you put a vacuum bag, and that is consolidated through an autoclave. So, you get a better consolidation. The processing steps, the part is placed on the prepeg on a surface in the open die. The difference is that the prepeg layers are spot welded here as compared to that of thermoset. The thermoset has good tack and wrappability. That means to say it can wrap over any sharp edge and sharp consolidations. Here it is slightly difficult. The complex shapes which can be made very easily with thermosets, and here since the material cannot flow so easily over the sharp edges, so sharp edge consolidation and complex shapes consolidation is not possible while using thermoplastic prepegs. So, the thermoplastic tapes, a releasing agent is applied at the mold surface so that it can be moved. All other things are especially the same. The vacuum bag helps in removing the air which are getting trapped at the interface, so you get a better consolidation. So, it is almost the same. The pressures are slightly higher, and then you have a vacuum pump to suck, and here is your composite. And again here you can have two types, one is simple, you can also have complex, and in complex also if you are smart enough you can have single or you can also have single curvature, you can also have double curvature to get the required output. So, heat applying, so it is the same way, the heat and pressures are applied here, but here the heat and pressures are not continuously applied, here the heat and pressures are applied only for a short duration. In thermo sets, you always apply for a longer time so that you get some chemical reaction, here you do not. So, the pressure is applied in two ways, by creating a vacuum inside the vacuum bag and then applying external pressure. So, two ways it is done, both ways are used for getting consolidated output. So, a vacuum bag is used by creating a vacuum inside the vacuum bag and an external pressure by the autoclave. So, the pressure serves two functions. One, it tries to remove the air from the interface and creates an intimate contact. Two, it helps in flow of the resin. So, for these two we always try to apply pressure. The resin, if it does not flow properly, it tries to create a interfacial problem and then there will be a lot of defects which are there. In order to avoid this, we always try to apply pressure along with heat so that we get the proper consolidation. So, the resin flow occurs once the temperature of the thermoplast is very close to that of their melting point. So, Tg is different, Tm is different, melting point. So, advantages, it is used for structural applications, the fiber orientations you can decide here, and then it is it tries to replicate the autoclave process of thermoset, whatever can be made there can be made here. So, here large components can be made, the thermoplastic filament winding and pultrusion components whatever is made can also be further consolidated to get a good output through this. It is used for making very small prototypes also. This is the only process in thermoplastic which gives you this freedom for making prototypes, and the all other thing, process parameters, tooling, everything is very close to that of the thermoplastic thermoset resin as far as this process is concerned. So, here as I have told, lack of tack and draftability is there, high capital investment, and it is the processing of thermoplastic is slightly difficult to that of your thermoset. Higher temperature and higher pressures are involved, and there is a component of viscosity which plays a very important role while trying to wet these fibers. So, some of the applications of these parts, it can be used in aviation industry, it can be used in defense, it can be used in electronic industry, car industry, trains today, rail transmission is also made, public security, sports and medical. Sports, lot of things are getting, lot of sports items are getting made out of thermoplast. So, this makes the product lighter and lighter and lighter, and on top of it, it is also making it tougher and tougher and tougher. So, wherever you want to have a compromise, so people are using this. So, thermoplastic composites are finding lot of applications today in sports. For example, tennis bats or racket, the tennis bat base racket is made out of thermoplast composites, and then which is reinforced with carbon fiber. So, it is very light, it gives you a huge strength, very light, and when you try to play, you do not get into fatigue. The same way helmets are made out of it here, and then the dive boards are made out of it, skiing boards are made out of it, which was earlier made out of wood, now it is made out of these applications. And for medical field also, several applications are used of thermoplastic composites are getting used. So, robo arms have been made because for several applications. Another interesting application where thermoplastic composites are getting used is underwater or marine applications. Lighter and lighter boats, lighter and lighter floating boats, floating bodies are made such that they can meet the requirements. And second thing is, in underwater as well as in marine, there is a tidal force which is which is random in nature and it is very difficult to control. So, there also thermoplastic composites are coming up in a big way. So, here the robo arms of 18-inch diameter and 72-inch long carbon peak composites are made of required orientation, and then final consolidation. They have been made through tape casting process, and then they have come tape winding process, and then they have come to autoclave process to get consolidation. The prepegs are spot welded so that they do not move, and then the entire process is done in autoclave. So, autoclave is the other big process. Autoclave process, you can put it in this way, it is used for better consolidation. So, this consolidation helps us to push the volume fraction from 30%, now we have gone up to 50% in thermoplastic, which is a big challenge, right, and then it is used for only consolidation. So, autoclave is not a basic process where in which you try to make the shape. So, rest all things is like you can make it through compression molding, you can make it through tape prep process, you can make it through pultrusion process and come here for better consolidation. So, you can do it. So, the last process for discussion as far as thermoplastic composites is injection molding process. Injection itself says it has to be an orifice, where in which through this orifice I try to pressurize the liquid or the polymer to get the required shape. So, the shape is given by the mold, that gives the shape. So, any shape can be made. And interestingly, you can also make sandwich products. So, where in which you have thermoplastic of glass fiber, thermoplastic of glass fiber, and in between you can have a core which is of a different material. You can try to make it. So, people when they try to make something like I-beam analogy, so you can also make this to get the required output. So, injection molding process is a very common process which is used as far as thermoplastic is concerned. So, here you can use use short fibers and these short fibers, what we do is we try to blunt them with thermoplastic. So, it when the short fibers are impregnated or incorporated, it increases the melt viscosity. So, that means to say the viscosity is going to go high. So, if the viscosity is going to go high, then you are supposed to give in more pressure for injection. So, the other method which was developed to overcome this very high pressuring is very high viscosity is the method of reinforcing reaction injection molding. So, here the reinforcement will be reacted and it is generated during the injection molding process. So, the other extension for this is reaction injection molding, which is called as RIM. So, in RIM process basically what happens is I try to take two different precursors made out of polymer and they are pumped at very high speeds and very high pressure, in fact Q, and then it is mixed in a head and then it is molded. So, where in which these two components react, polymerize and give me the required output. So, those process is called as RIM process, which is reaction injection molding process. So, here the raw material in injection molding process will always be a pellet. So, the pellet can be thermoplastic with glass fiber reinforced, thermoplastic with whisker reinforced, thermoplastic with ceramic also. Okay. So, depending upon the requirements you can choose the pellet. So, these pellets are basically extruded and then they are cut into small pieces, so that you get the small button like structures. So, these pellets are put inside the injection molding machine. So, the pellets or the granulars is the shape which we have, and then we try to get this. They also can be a coated strand that are chopped typically of a required length of 10 millimeter length, so that you get the required output. So, the pellets are made and then once the pellets are made, these pellets are asked through pass through, okay, pass through a barrel, and in this barrel you try to apply high pressure, high temperature, and then you try to, the other end of the barrel is attached to a nozzle, and through this nozzle very high pressure you try to inject it inside a die, and in that die the part gets consolidated to make a required output. Okay. So, that is what is the entire process. The final mold part contains a fiber that can range from this to this, and then the fibers, when it passes through different parts of the injection molding process, can get broken down. So, it is always advisable to use small reinforcement to it. So, the general matrix which are used is polypropylene, nylon, PET, polyester, etc., and the pellets are made out of carbon, Kevlar, glass as well as ceramic. So, tooling. So, let me explain the machine first and then come here. So, this is the pellet, this is a hopper. So, here you put the thermoplastic composite, thermoplastic composite granule are put inside this. So, these granules can be a fiber, chopped, whisker, or a particulate. And then what happens is, this is allowed to move inside a barrel. In this barrel you have heaters, this heaters heat the barrel, and then the pellets which fall down has to be slowly moved towards the other end of the nozzle such that it gets injected into the die. So, what happens is, there is a screw, this screw keeps rotating, and this screw has an interesting geometry. It has a taper, and this taper is inverse taper. So, the gap keeps on reducing as and when it moves towards the other end. So, what happens is, at the initial there will be huge amount of gap. So, a lot of pellets fall in this, and then it gets the screw moves, rotates, and so the feed also moves forward. So, there is an inverse taper. So, as and when the space is less, there is friction between the pellets which is moving, and there is a heat which is getting applied. So, this tries to increase the temperature, and because of the increase in temperature, so they go to a viscoelastic state, and then through that viscoelastic state we try to inject it in through the nozzle to the die, and then we try to get the shape whatever we want. The die design is a big challenge. The splitting of die which leads to parting line. So, this parting line has to be found out, and then we try to decide the die to get the required output. Once the part is made, then we use the ejector pin to eject the component out to get the required output. So, this is the complete injection molding process. So, here the thermoplast is made into pellets. So, these pellets are used to make the required product. So, here, so a steel mold with single or multiple cavities. So, here what we saw is only one cavity. You can have multiple cavities. With the injection molding you can get the required one. The steel are always chosen to such that they have lot amount of fatigue resistance. The mold with tool steel is typically 5 to 10% more costlier than steel. So, we always make multiple cavity molds, can increase the production. You can also have single, you can also have multiple. Single means large part. So, multiple means surface to area is surface is large and area is small. So, this is large. So, you make multiple components, for example, spoon, plate, all these things. So, you also use this pellets which I have already discussed. So, injection molding machine, there are two types. You can have reciprocating type, or you can have reciprocating type. You can also have a reciprocating screw type. So, reciprocating screw type barrel is one we discussed here. So, here there is a screw which keeps rotating and keeps moving, so that you can try to move the material from one extreme end to the other extreme end, and then it gets injected. So, the other way around is you can directly use a reciprocating plunger. So, you fill all the ingredients, the charged material, and then you just push it inside. So those things are called as plunger based material. So it is one shot process. So the entire stock which is there is consolidated, pushed into the die, and you get the output. But whereas in injection molding it is continuous, you can keep going. So the cylinder temperature is increased to melt the raw material, and as and when it moves towards the nozzle. So the purpose of heating is heating the cylinder is to transform the solid into a viscoelastic liquid and then force them through the nozzle, sprue, runner, and through the gate. So that leads to a mold cavity, so that you get the better output. So the sprue, runner, gate, all these things are, say for example, basically you have a nozzle, and then this nozzle, if you directly inject, it will try to restrict the flow. So what we do is we try to reduce the flow in multiple ways, and so that we get a better consolidation and curing. So those things are done by the sprue, runner, gate, and then you get the final component. This is the component. This is how it is linked. Okay. So if you study injection molding in detail, you will understand the need for sprue, runner, and other things. Basically sprue, runner, and the gate are used for pushing the thermoplast resin along with the reinforcement inside the die in a very controlled fashion, and it also tries to allow you to solidify much faster. So the processing setup, the plunger forces a controlled quantity of the material into the through the nozzle die into the closed die. So the viscoelastic liquid is injected into the cavity and allowed to cure. So the mold is held tight, and then it is held for some time such that the temperature comes to TG state, and then you start consolidating and releasing the component. This we have dealt it in detail. So what are the advantages of this process? The advantages of this process is, so any complex shapes can be made. It is a one shot process, any complex can be made. This process, it has a very good repeatability. All the injection molded components, plastic components, all those components can be made through this using the pellets, wherein which you have reinforced with some glass fiber or carbon fiber or Kevlar fiber. So the process is the same. The dimensional accuracies can be high. It is very high volume production. It happens 20 to 60 seconds is the processing cycle time. So it can be used in any of the applications. A very huge application industries are now focusing on it. So it is low labor cost. So and whatever is the scrap is reused, so that you try to get a required, so that you try to recycle the part. The disadvantages are, yes, it needs to have a huge running cost is one, and suppose you want to make only 25 parts, small prototypes cannot be made because the barrel length is too high, and it is not good for small volume production, and it needs to have a die, and die designing is very difficult. And on top of it, there are some process variables like injection pressure, back pressure which gets built, melting temperature, mold temperature, shot size. All these things have to be optimized to get the required quality output. So back pressure is, see, you are trying to inject it, and if there is a resistance which is given because of the air gap or something, so that is the back pressure which is there. So that also has to be balanced to get the required output. So these are some of the components which are made out of it for several applications. So today all these things are now started getting into structural applications. So every structure what we make, though here whatever we have displayed is thermoplastic components, but in reality what is happening is all these things are now converted into reinforced parts which are using for structural applications. So these are some of the parts which are used for sockets, equipments, and it has now got into the entertainment industry also. We are trying to make much lighter parts. So with this we come to an end to the different processes which are made under thermoplastic composites fabrication. Thank you very much.